Welcome to the project demonstration of battery management system, that is BMS, state of charging and passive cell balance, active cell balancing. So this project is advanced features to calculate SOC, nothing but state of charging, how the battery voltages levels are increasing when we are providing the constant current source to charging of the battery pack, as well as next temperature also continuously monitoring with help of this temperature sensor, and this is for thermal protection purpose. And the third feature is passive cell balancing. Passive cell balancing nothing but whenever we are monitoring the battery pack, this consists of 3 battery cells. So this battery pack we are using of 12 volt 1 amp. In that 3 cells are connected in series. So when you are demonstrating this project, the international courier, we can't provide these battery packs. So you need to arrange these batteries. Each cell is 4 volt 1 amp, or an availability of batteries, lithium ion battery also we can use this for the project. That is a 3.7 volts or 2 amps or 3 amps or 1.2 amps, whatever it may be current rating, but the voltage should be 4 volt or 3.7 volts. The 3 batteries should be in series. So you can see that this one is a negative and positive, negative, positive, negative, positive. So these two are in series, these two are in series. Total 3 batteries are in series. So we'll get 12 volt to 1 amp, the addition of the voltages. Same for this 2 battery packs, we should arrange them like shown in this manner. So coming to the passive cell balancing, whenever the battery pack in this battery pack 1, so if the battery of this cell 1 voltage is less than cell 2, then the cell 2 voltage will be decreased to the level of this cell 1 voltage. So means reduction of the voltage to make the same voltage levels in the battery pack is called as a passive cell balancing. And coming to the active cell balancing, to increase the voltage levels by sharing them. For example, this is a 3 volts and this one is a 4 volt and this one is a 4 volt. When you are using the 4 volt each cell of battery pack, then the excessive voltage from this cell 1 will be transferred between these cells. Means the excessive voltage of 1 volt will be divided in the low voltage cell, and again remaining also will be transferred. The voltage sharing will be done, so that automatically the active cell balancing will be achieved. So this concept will be achieved with the help of this 8 electromagnetic relays. So battery pack 1 for this 4 relays, battery pack 2 for this 4 relays, and the so-called status continuously monitoring and displaying on the 16:2 LCD screen. To achieve this active cell balancing and passive cell balancing along with voltage measuring, we are making use of these 2 voltage sensors. So each voltage sensor for each battery pack, and that will be connected with the help of this electromagnetic relays. And all these input and output modules of our project interface to the PIC16F72 microcontroller. So the input is nothing but temperature sensor and voltage sensor 1, voltage sensor 2. All these are interfaced to the pin number A0 to the temperature sensor, A1 to the voltage sensor 1, and A2 for the voltage sensor 2. And these 8 relays are interfaced to the C0 to C7 and B2 to B7 for the 16:2 LCD screen. And these are the main input output connections of our project. We can provide the 230 volts AC input or 100 volts AC input to this transformer, which is used to step down the 230 volts AC to 12 volts of AC. And once step down is done, then we need to convert that AC to DC with the help of this regulated power supply board, which will take 12 volts of AC input from this one and provide us a 5 volts of DC output from these 2 cables and 12 volts of DC output from these cables. So these are 12 volts of AC, 5 volts of DC, and these 2 are the 12 volts of DC and 12 volts of DC. That is the charging voltage to these battery packs through these relays. So these are the major input output connections of our project. So before demonstration, we need to connect this battery pack to these crocodile pins. So there we have mentioned clearly this is the ground of the battery pack. Right, so there you need to connect this negative ground. Consider, so these 4 are the battery pack 2, these 4 are the battery pack 1. So the negative should be goes to the connecting very gently, should be goes to the negative of this battery pack. Okay, see the negative, positive, negative, positive, negative, positive, and then next is the 12 volts. So this 12 volts should be goes to the last positive. Okay, so from here to here 4 volt, from here to here 8 volts, from here to here 12 volts. So again the 8 volts should be goes to here. So while connecting, generally this should not be short circuited. And the next 4 volt. Okay, so right now this was a ground, negative 4 volt, 8 volts and 12 volts as we mentioned here. Same like manner we need to connect for the battery pack 1 also. This one is a negative side, and again after negative the first one is the 4 volt as we mentioned, and the next one is the 8 volt. So here we mentioned, and next is the 12 volts. Okay, so after this successfully paired, now we can on the power supply to this power cable. So on LCD welcome message will be displayed, and later on we can see the each and every relay will get switched on, and the voltage will be calculated and displayed here. So whenever the voltage is less than the threshold value for doing the active cell balancing or passive cell balancing, it will keep on doing that with help of this relays only. This input is a charge voltage, means how much of voltage we are providing for the battery pack charging. This one is a overall battery pack voltage, and the next one is the 2 batteries, and next one is a single cell, means single cell, 2 cells, 3 cells, and what is the charging voltage input. And then of the temperature. So if the temperature of this battery packs continuously monitoring on this LCD, so we can see this. When we increase the temperature, we can get the temperature value also will be increasing on the LCD. So you can see that the voltage is getting increased. Okay, and SOC also, as of now the battery is getting fully charged properly, that's why we are getting the SOC of nearby 100%. Right, you can see that as we are using the healthy battery packs. When we are using the unhealthy battery packs, there we are going to get the abnormal SOC values over here. Right, so you can observe the each and every relay getting switched on to do this operation of main requirement of our project, that is the passive cell balancing and active cell balancing. Right, see, if we remove this, means the 12 volt sensor got disconnected, we are getting that 0 volts here. So if we remove this, so while doing this, crocodile pins gently connect them. Right, you can see that 8 volts is 0. Okay, and use the battery pack 1 to the battery pack 1 crocodile pins only, and battery pack 2 to the battery pack 2. Don't mix them, as it leads to the burning, as the negative positive will be short circuited of these battery packs. Right, again it is normal condition. Right, thank you.